Okay, starting the recording. Welcome everyone. We're back at week 3, day 3, part 1. 331. It's almost a great band from Omaha with that name. Come on, folks. What we're going to do today is we're starting off probably the first half before lunch, or before the break, not lunch. We're going to be talking about SQL joins, and we're going to be showing how we can have data across multiple tables that is related. That is very important that that data is related. And we're going to be able to query for data where that data is related. And the reason why we store data in multiple tables is I haven't really gone too far into detail with this, is that it allows us to not have to duplicate data across tables. So I'm pointing over at a whiteboard that has a users, items, and an orders table. And that allows us, having the orders table allows us to reference the user table without having to copy the user's name over into the users table or into the orders table. Because imagine that you, as a user of a website, would place an order. And let's say that that website incorrectly just copied all of your customer data and put it into the order instead of referencing the users table. Well, what side effects might that have? Well, down the road, when you decide that you want to change your last name or your first name on your user profile, or maybe even your username, what's going to happen is that it will either need to manually update the orders table and say, oh, by the way, this person's name got updated, so we need to match those two, or you're going to fall out of sync. So, because you probably would do some query where you're like, hey, I'm logged in as username Joel. I want to go to my orders history page. So the query would go to the orders table and say, give me all of the orders where the username was Joel. Well, that's because it was duplicated. I didn't have to do a join. So that upfront cost was very low, and it worked really well. But then a user went in there and changed their name from Joel to like Joel Internet Guy or something like that. And now it didn't update the orders table. So when I go to my orders page, it says, hey, go get me all of the orders for where the person's name is Joel Internet Guy, and it doesn't show any. So that's a bad thing. So we'd like to have the references there based on the primary key because that doesn't change. That's a huge note about a primary key, is that you don't change it. Very bad things happen when you update an ID in a database record. So that's one of those like never do it type of things. And if you do it and someone asks you why you do, don't bring me into it. Just be like, oh, my teacher at Carolina Code School says it was fine to change my primary key. And I'll probably just sense that you said that, and I'll call you up and say, don't bring me into this, because I would never do that. If you did want to do that, if say you're like, I need to change this thing's primary key, typically the workflow for that would be to copy the record and then delete the old one. Now that's not going to be easy, because that old record probably has items pointing at it, or it's probably pointing at items. That's going to cause a problem when you delete it, and it should cause a problem when you delete it, because you don't want it to be easy to screw up your data. And so that's sort of that deliberate step where you create a new record, you go in and run a script that says, hey, everything that's pointing at this old record now needs to point at this new record, and I'm going to drop that old record. Why you would do that, I don't know, but I'm sure you'll find a use case over the years in your career. If there's one thing that has surprised me, it's that I really shouldn't be surprised anymore at all the crappy data situations that databases can get themselves into. And it's not the database's fault. It's typically the programmer's fault. Well, it's sort of a mixture of the programmer and the user's fault of getting the data into a bad spot. But it is a problem in programming. You will encounter it, and there's chances are, depending on the organization, you're probably going to have to be the person that fixes it by yourself, and it's probably going to take you a long time. So you have that to look forward to, I guess. It's just a matter of time of when you will have to do it. Hopefully it's not within like the first year or so. Hopefully it's more like a couple of years in before you have to do stuff like that. Okay, So let's get started here today, and I'm going to create like a little scratch file in my week 3 work directory. I'm not going to make a .py file. I'm going to make a .sql file. So I'm going to say this is going to be day 3, and we're going to call this joins.sql. Sweet. By the way, in SQL, a comment is hyphen hyphen, whereas in Python, a comment is a hash mark. You say hyphen hyphen is your comment, and then you can type all sorts of crap in there, and it doesn't have to matter. So I'm not gonna write a SQL script here. Really, I just named it a .sql file so I would get syntax highlighting. And this is also how sometimes I will do some data cleanup stuff, because one thing I'll almost never do is go into pSQL and start just writing a query right there in that little command prompt like all of you were doing. I don't ever want you to do that again, because that's really painful. Like, you make a typo, and then what do you do? Like, you have to force an error, hit the up arrow, and then retype it again, or it's like find the semicolon in the blanket kind of thing. So what we're going to do is we're going to type all of our queries in this file here. We're going to use syntax highlighting to help us to see what's going on, and then we're just going to copy it and paste it into the command prompt here, run it, see if it gives us an error or not. And plus, this way, I can just write out my my SQL commands here, and you can have them forever versus just running it and then they're gone. So not really a good idea to just run them and have them gone. So I'm going to break down today's lecture, or today's half of lecture, into a couple of parts. Is that I'm going to, step 1, we're going to create a few tables. Let's do a users and items and orders. Like, let's do exactly that up there. I think that that's cool. So let's say we're going to create a users, items, and orders tables. Or as they would say in the mall, table. Step 2, we're going to create some data for those tables. Just some fake data, it doesn't have to be real. In step 3, I'm going to try to run some interesting queries. When I say interesting, I just mean, like, you know, when you have data that's related like that, you can ask some real convoluted questions. It's not just, it doesn't stop at what has Joel ordered. It could also be who has ordered bread, or who bought bread for less than $2, or has Joel ever ordered bread? And you can ask it by name. Like, literally, you could say, has Joel ever ordered bread? Like, those are the kinds of questions that I want to ask. Because typically that's going to be how, when you are tasked with database questions, like if you're ever said, like, hey, we got some bugs, go find it in the database, typically somebody is going to come to you that is not technical, and that's fine. That's not like their fault. It's just that they're going to ask a question to you to say, hey, can you find me X and Y? They don't know the database structure. They're just going to ask you, how many pieces of bread did Joel order yesterday? And you are going to have to think, okay, well, let's see what the database structure looks like. And you're going to take that and you're going to convert that to SQL in your brain. And today's the first day that we get to start doing that, because you're never going to stop doing it your whole career. Just that day in and day out never ends. So step 3 is going to be, we're going to ask interesting questions on the data. Emoji, or emoticon face. And let's also do a heart. Although it looks kind of like a dagger that's going to stab the face in the face. All right, so let's type out our 3 SQL commands that are going to create our tables. So what's the SQL command to create the table? Sometimes I will ask an extremely stupid question and expect an extremely straightforward answer. I'm not trying to trick anybody. So we're going to create a table, and let's create this one called users. Every table, I don't care what you're doing, in the scope of this class, every table will have a primary key, an ID. You will eventually work on tables that don't have primary keys. That's fine, but not in the scope of this class. Every table that gets created in this class will have an ID that will be a primary key. That's a real easy way just to remember it. Like, should I put an ID here? The answer will always be yes. So we're going to start with our ID. Since since when you query a table without specifying the columns, it will always show you the order of columns from left to right, from the first defined to the last defined. I always like to put ID first because that will always be in that left margin, much like a Excel spreadsheet will be. So it's always nice to have that in that left margin. Who remembers the keywords you put in here for ID? Serial and primary key, right. Do I have to put integer? This is a tricky question. Do I have to put integer? No. Why not? It just does it. It knows it's not that smart. We specifically said that it's not an integer because a serial is technically an integer. It's just an auto-incrementing thing. Okay, the users table, we're going to store the name. So we're going to store name. We're going to say that that's going to be varying character, and let's say that that's like 30 characters long. People with really long names are going to complain about using our service. We're going to have an age, just really to fill in space. That's going to be is it numeric? For 3, correct. Now let's specify this. I don't want the name to be left blank ever. I don't care about the age, because the age is like, I really don't care. So with the name, we can add on to the varchar specification. We can say not null. And what that means is that whenever I create a user, it will require me to give to provide a name. Because what is a user without a name? A user is not just a number. A user is a name, an age, and a number. And we're going to put a semicolon right there. Okay, we're going to do the same thing with the items, which is pretty much the same table. So we're going to just kind of knock that out real quick. You can type it at your own speed if you want to go super fast, but I will explain everything I'm doing. So I'm going to create a table called items. Its ID will be serial primary key. I'm going to give it a name. And column names don't have to be unique across tables. So we could say name, which is a varchar of 30, and then it's not null. And it has a list price, which is a numeric. And let's say that's going to be 3. We don't want to have anything too expensive in the. And we could even probably make it like a decimal type as well. Let's do that. Let's make it a decimal type. So we can say that's decimal, and we're going to provide 2 numbers, which is going to be 3 and maybe 2. And if I'm remembering correctly, which happens often, the decimal type's 2 parameters that we provide it tell you what is the accuracy. The first argument says what is the number accuracy to the left of the decimal point. So when you see on a number line, that's like anything above 0. And the 2 is saying what's the accuracy to the right of the decimal point. Meaning, hold on a second, I'm getting. So that means that we're only going to be storing cents. So we don't need to worry about half pennies or anything like that. This is not Office Space or Superman or anything. So, cool. That's all we need there. Now we're going to create an orders table. So we're going to say create table orders. And by the way, this is probably the last lecture where we write SQL. Or this is probably the last thing where we put SQL together. Because after that, we're just going to have something write all the SQL for us. Swish. So I wanted to make sure I said that so that when we got to the SQL, you didn't feel betrayed. Or when we got to the ORM, you didn't feel betrayed. Like, oh man, we spent all this time learning SQL, and now it's just going to throw it away. No, it's important to know what that thing is doing, and it's doing a lot. Okay, so in our orders table, we're going to create an ID, which is a serial primary key. And now we are kind of different now. Now we're getting somewhere a little bit different. We need to specify our references, like our foreign keys, or what we'd call a foreign key. Now that's an important part of terminology there, is that the primary key is the ID here on the table, which sort of like states who it is in a unique fashion. Like I am 4, I am 8. No one else can be 4 or 8. A foreign key is pointing at another table's primary key. It is that sort of outbound reference saying that, so if I have a user ID here, that is a foreign key that's going to say I am going to point at the ID of the users table. So let's see what that looks like syntax-wise. So we're going to say we're going to make a user underscore ID, and that is not required, but it is an amazing convention that I would love to see all of you use. I need you to steal that convention, is to have the name of the table single, like not pluralized, and the underscore ID after it. That's very important because we are not storing a user here, we're storing a reference to the user. And so that's going to be, and because it is a reference, we're going to say that that's going to be an integer. I can't spell integer. Integer. There we go. That was painful, wasn't it? It's going to store an integer. Integer. And that's going to have, it's going to reference another table. So we need to tell it that that references the users table, and it's going to reference the ID column for the users table. You know, if I'm not in Kevin's way, I'm in John's way. So if I've done this correctly, that will make it will put all of the database constraints that says that that user ID is not just a dumb number that's sitting there calculating something. That number means something. That number has an inherent relationship with another table. And that's okay. Okay, we're going to do the same thing with our items, or our item that the person ordered. And so we're going to make a column called item ID, which is an integer that references, my spelling game is not on today, guys, the items table ID, because that ID is the primary key.
So you could tell it to reference any of the fields. I mean,
it could, but I believe it has to be marked as a primary key. So if the ID is not the name of the field, which ID doesn't have to be the only primary key. You could even have what's called a composite primary key, where it's made up, a primary key could be made up of 2 columns. Don't worry about that, though. We're not worrying about that. So yeah, so you could point this to reference to any column on here. The problem, though, is that if it is pointing at a text column, not a number column, that is going to be a much heftier computation on your database. Because think about how, like if you were a computer, what would you rather compare? A number or a string? Like a number is it can be converted to binary very, very quickly, and then you could just line the zeros and the ones up, and you can say, yep, nothing fell through, we've got the same number. With a string, though, you have to go through each individual character, convert that to binary, and say, does that line up? Yep, and then it goes to the next one. Does that line up? Yep, and it has to do that. So if you have a string that's 30 characters long, when it needs to make that jump across tables, it's a much heftier computation. And granted, for our use cases, we probably wouldn't even feel the pain of that. But the minute your table starts to make your company money, it tends to grow out of control, and then you have what are called scaling problems. You know, when you have you see news articles, we could probably go to Hacker News right now and have somebody talk. I could probably just Command F scaling. Oh man, damn! Now I feel like an idiot. Sometimes I feel like Hacker News always has a thing on scaling. It's like, what the heck is scaling? Well, scaling is just your application's ability to work better as it grows, or to work the same with 0 users as it does with 1 million users. So that's what we're going after. All right, and then the last one we're going to do is going to be the price that we paid, which we could just do the same thing. It's a decimal type of 3 and 2. Okay, so let's go to our command prompt, and let's go run these. And I'm not going to run all of them together. I typically won't do that because of the obvious reason of what if one of them breaks? then that means I'm going to be stuck with like maybe 2 tables and one that's broken, and then be in a weird spot. So I would rather run it, have it tell me if it worked or not, go to the next one, worked or not. If the third one doesn't work or not, then we can address that like right there. There's no question about which one broke. Okay, so let's all jump out to our terminal now, and we're going to create a DB. We're going to do create DB. This is going to be orders underscore DB. And then we're going to pSQL into the orders DB. There we are. Slash display tables. Let's see what's on there. We don't have any relations. So let's create some. And at this point, I'm going to copy and paste each of the individual SQL create table commands into here. And you'll notice that it won't run it. It will just sort of sit there, and it'll be like, okay, now go. And I'll hit enter, and it won't error on me. Let me know if it errors on you. We're going to hit the brakes if it does. So we probably have a syntax error in our SQL. I'm going to do the same thing with the items table. Hopefully everything should be fine here. Oh, that one ran on its own. Oh, that ran on its own because when I selected it, I didn't just stop here at the end there. You see where my cursor is? The cursor is up at the beginning because I selected up. If you select down, though, watch what happens. If you get that new line right there, see how my cursor is blinking right there on line 16? That will copy the new line character over, which will act as you hitting enter when you paste it in. That's why it's not safe to copy and paste things from the internet. Because you might be copying a command, and then there's some hidden HTML that you just copied. And then there's a new line character that you just copied as well. So when you paste it into your terminal, it just runs itself, and you can control C, but maybe it might be smarter than that. So be afraid, be very afraid. Okay, so it looks like our tables are being created. Let's say /d items /d users. If these look good, I've got an integer primary key that is going to go through the sequential number. Primary key uses a B tree. Good. Now let's copy our orders and see what happens. Let's see if this works. Cross your fingers that it does. So /d orders. Look at that. That references thing that we did. Look at all that stuff it typed out for us. It built constraints on the database table. It indexed both of these, or it has 3 indexed columns on it, which means that, so an indexed column you can think of as in a very rudimentary fashion. It's a way of trading hard drive space on your database with database speed. So when you want to look up by a user ID or a item ID, or you want to join across the table, the index itself will store the immediate location of where that is in the database on the hard drive. So, and the good thing about that is that if you're indexing primary keys and foreign keys, what did I say about primary keys that you should never do? You should never change them. So if your data isn't changing, you don't need to rewrite to the index. It's just there, which is a very fast operation. So don't worry too much about what all that means. That just means that we're doing things right. Okay, this is great. So now we can start creating some data. Or no, let's see. We're done with step 1. Woohoo! Mark that one off the, I wish there was a strike through, like a shortcut that I could just say strike through right there. I love strike through. But yeah, so that's done. So we've only got 2 more things to do. And I think that creating the data for those tables, we've already done that a lot. We've already done plenty of that. So I'm going to come down here below the create tables here. And I'm going to say, now let's create data. So what is the SQL command that I want to use to be able to put data into my table? Tables. Insert. Yeah, definitely. So let's write some insert rows for the users. So remember the syntax is insert into, I'm going to say users. I don't want to specify the primary key. So I'm going to specify the columns to say name and age. Then I'm going to say the values are going to be, and remember it's a single tick quotation mark, is Joel 34. Now since we're just going to create masses of data, we can just copy and paste this insert into command a couple of times. I'm just going to change the name. You can put your own information in here. You can put your friend's name. You can put their ages in there. I really don't care. It doesn't really matter. We're going to put Peanut and Audrey. Put Logan. Okay, I think that's good. We have 5 rows in there. At this point, we can just copy and paste this into our terminal, create some data. Now it's probably, it'll run all of them except for the last one. I think the last one you're just going to have to hit the enter key. So you see how we had to do that? Like we paste the first 4 in there, and then the 5th one we actually have to hit enter. Now how would I, what kind of query would I run to make sure that those went into the users table? Yeah, we do a select star from users. And all of my data went in there just fine. Yay! Don't ever forget the semicolon. Don't worry, after working in JavaScript, you won't. There are some languages that won't even work, like just like SQL. Like, you know, if your productivity is that you forgot the semicolon, you're not going to have a very productive day. Okay, so now we're going to insert some data into the items table, and this should be fun. So I want you all to be creative. So I'm going to say insert into items, the name of the item, and then its list price. Provide some values, and I'm going to do, I don't want to do food. I hate doing food analogies. Let's do furniture. I'm going to do a chair. And a chair is going to be like 123.12 cents. I'm going to do a TV, which is what, like $9? Yeah. Back in my day. Well, I just can't make any items that are above 3 digits. So like I could say this TV is $900. That would make more sense. Let's have a hot tub. This hot tub is going to be $920.45. Actual retail value price is a new car. We're going to have a cup of coffee.
It's from Starbucks, that price can still be accurate.
Yeah. Yeah, but let's go with $5.95. Cup of ramen, 95 cents. Which is still probably wrong. They're probably more like 45 cents.
30.
I said I didn't want to do food, so we're going down that path. We don't want to do that. And then we've got a office supplies, which is like a box of office supplies. We're just gonna say is $19.99. Okie dokie.
For the ramen, do you have to put the 0? Like if you just put 0.95, would it freak out?
Yeah, I believe you do have to put the 0. What the heck is that floating point website? You're talking about decimals. That's funny. Oh man. Don't do that. All right, so let's go ahead and copy and paste that into our command prompt, the insert into for items. See if that works. Nope. We got a numeric overflow error. A field with precision 3, scale 2 must round to an absolute value of less than 10 to the 1 power. Oh, what did I do wrong?
Did backwards.
Oh, the TV did. Well, no, because I got the same error.
Yeah, I probably put it backwards. Let's see if the chair, because it looks like these two items went in. So the cup of coffee and the cup of ramen went in. Okay, that's fine. We'll just have it. Okay, I screwed that up. Sorry, guys. Let's say a hot tub is $1.45. Office supplies are $9.99. Okay, so so cup of coffee and cup of ramen ran. So pretty much anything that was more than $10 wouldn't have ran. Oh wait, no. Yeah, the TV worked too. So I'm copying the chair in there, copying the hot tub, copying the office supplies. Right? Office supplies. Yeah. I got it backwards, didn't I? Oh well, I've made mistakes. Let's select star. Wow. Values. Nope. Items. My brain didn't work there for a second. Let's do a /D on the items table. Oh, it just says numeric 3 too. Let's look more into that. Maybe I flipped them. But we have items in our items table. So now we can start creating orders. And I'm just going to have 2 orders for us to start with, because we'll create more orders as we go. So I'm going to say insert into orders. I'm going to say that we're going to specify the user ID, the item ID, and the cost. Got to remember that now we have to work with that cost in mind. So the user ID, well, we have to know what the user, when we insert into it, we have to know what the user and the item ID are.
Is cost supposed to be a new variable or it's supposed to be price?
Did I say price? Yes, thank you. I made a mistake there. That should be price. All right, so I'm going to provide the user ID. So let's say Joel is going to be 1. Joel bought a TV, so that would be 2, for $8.95. By the way, I'm doing this very deliberately because eventually I'm going to run a query to look for people who bought items not at list price. All right, let's try to insert that into our table. It looks like it worked. When we select star from orders, it should look just like we have over on the board. So Joel bought a TV for $8 and 95 cents. Okay. Let's create a couple more orders, and then we can just start playing around with the questions. So let's say insert into orders. Let's say that Joel also bought, whoops. You can just copy and paste this row. Joel also bought a chair for $3. And I'm going to copy and paste this line a couple of more times so that, say that Sarah bought a cup of coffee for $5.95. Say Logan bought some office supplies, 1, 2, 3, that's 6, for $8.99. He got a $1 discount. And let's also say that Joel bought a chair for $3. There we go. I like that. So Joel has 2 chairs Yeah, that's a good orders table. Let's go ahead and copy and paste the rest of those in there. Not the first one though, unless you want to duplicate that. So this is what our orders table looks like now. It has it has its primary key, which is an ID, has a user ID, has an item ID, and a price. Sweet. So remember what was the constraint that I said that I had imposed on myself by designing the database like this? What corner had I painted myself into at the very beginning when I was diagramming that out? How many items can I have per order on this? 1. So it's not a great solution, but it'll work, for now at least. It illustrates our points. All right, so let's go back up to our to-do list, and we created some data for these tables. D-U-N, done. Who's ready to ask some interesting questions of our data? Because now we're going to get into the join syntax, because what we've done, because you can't really do joins without foreign keys and primary keys. When I say foreign keys, I always refer to that references thing. Primary keys is always going to return to an reference mapped in your mind to a ID column. And so let's ask some questions. First off, I want to ask a question of this database. I want to know the item's name that Joel has ordered. Or no, I just want to show all of the orders that Joel made. So this is where queries start to get kind of big. So first off, to get all of the items from the orders table, we would just say select star from orders. But I need to be able to get the ones that by Joel's name. See, that's not what we want to do though, because I never said I wanted to look for the orders where the user ID was 1. The business person said, I'm the business person here. The business person said, go get me the orders that were tied to Joel. And you could just go do a query and say that, okay, Joel's user ID is 1, so I'm going to do that. Or you could do a join like this. And the reason why we're doing a join is because you won't program you shouldn't make your programs to go do that. Like I need to go get the ID for Joel and then I'm going to query the other one. You want your programs to run efficiently. And so what we're going to do is we're going to do it all in one command. And unfortunately, we have to learn new stuff to do that. Unfortunately. So we're going to select star from orders, and we're going to join the users table in this query. So that there are types of joins, but in this case, we're going to do an inner join. There's an inner and an outer join. We're only going to talk about inner joins today. It's actually a fantastic interview question for anybody that lists SQL experience on their resume to ask what the difference between an inner join and an outer join is. I wouldn't worry about that today. So we have an inner join, and then we tell what table we want to join to. So in this case, we want to join to the users table. So we're going to say inner join users. Now every SQL programmer will have their own sort of style in where they hit line breaks, because in SQL you can put line breaks wherever you want to. I like to do a line break on any new big command, like a where clause or an inner join or something like that. So an inner join to users is going to get its own line. These are still one command though. So it's going to inner join to users, and I'm going to have to say how they join. Because I might want to join in some incredibly weird convoluted way. It's not just going to default to the foreign key to the primary key. I have to tell it I want to join to those columns. So I'm going to say inner join the users on, that's capital O-N, and I'm going to say the table name orders and the column name on orders, so it's dot user underscore ID, so orders dot user underscore ID is the same thing as users dot ID. I'll let that, there we go, I'll put a bunch of new lines there. So that is my join clause to the two tables to say that orders.id or users ID is equal to users.id. That's saying that that is pointing at that table. We're going to join to it. I need to sneeze, but it's not coming out. It's constipated. Okay, so let's put a semicolon there. Let's just see what that itself does. I want you to see the resulting query results when you do just that. Watch this. Like it made this sort of Power Rangers Megazord of data. So before, when we just queried from orders, it gave us this. But when we joined the two columns or the two tables together, and we said how they were going to join together, it went like this. It interlocked them. And it made one new resulting table for our purposes of display. Now, this table didn't get created in the database. Like this result set, like it's like all sorts of new things put together. Like that was something that was kind of confusing to me when I started in database programming, was like, this looks like a table to me, right? Like, you all agree that this looks like a table. And so my mindset thought that this join is going to create a table somewhere in the database that I can query later. That's absolutely not correct. So if your brain went there, which is a very natural place for it to go, because mine went there, this table is only created once for the purpose of this query. And then after it's created, it gets thrown away. And so it's not even really a table. It just looks like a table. It's a result set. But we have all of the data we need here. So I'm not done, like I said, I'm not done with this query. And remember the question was, we don't want to look it up where the user ID is 1. We want to look it up, so I want to say where the users table dot name is equal to Joel. So this is the name from the users table is going to be equal to Joel. Now let's copy and paste that command into our terminal, and let's see what happens. All right, I've got all of the orders for Joel. We successfully created 3 related tables. We joined one of those related tables, and we were able to ask for it by human-readable terms. Where do you think this might come in handy in like a web application? Like what web applications have you used that, like, okay, I need to look it up not by user ID, but by some word or something like that? If you've ever typed a search into a website or something, say I want to look up headphones. Well, I'm going to tell you right now that like the items that are all stored right there, they're probably going to have a reference to this word headphones somewhere, because the bigger data you get, the more it's going to be all over the place. So there's going to be some form of join where the human readable version of it is headphones, because that's what you just typed in. It's not going to just type in where it's 1. Maybe it will. I don't know. There's probably optimized ways of that I just don't know about. But yeah, so that is going to be where it filters down to. So if you have a command, or like a command line application like sports database, and you want to go get and so instead of having it all in one table, let's say you have a stats table that has a reference to a player, and that stats table also has a year on it, so you can have like that player's 1999 statistics, their 2000 statistics, their 2001 all in one table. You could say, I want to go get all of Joel Taddy's rushing yards between 2000 and 2005. So won't worry about anybody else's stuff. Just worry about that one. Anyways, I'm getting kind of off track here. So that's really great. We did it. We got a join. We're kind of running out of time to play around with this, and I'm accomplishing pretty much everything I wanted to. But let's do more complex, or not more complex joins, but let's just do more joins. So I'm going to copy and paste this command here, and we're going to do more things to it. So I have the orders. let's say I also want to get the items details. Like I don't want to show, like, yes, I'm showing all the orders, sure, whatever. But I want to show, maybe the question is, what items has Joel ordered? Not what items here, what item IDs has he ordered? What are the item names that he's ordered? So I'm going to do another inner join because I don't have that data available on the orders table. I need to inner join to the items table. I'm going to say items, and then I'm going to say that's going to be on orders.item underscore ID is equal to items.id. See how it gets kind of repetitive here? That's the sign of a good naming convention, is when it looks like it's getting repetitive. Okay, so since adding that join, so if this was the resulting table of just joining to the orders and the user table where the name is Joel, let's see what the resulting result set is when I join to the items table, and then I say where the name is Joel. Watch this business. So now the table just gets wider and wider and wider with data. And as you would expect, if we had a database that had 100 tables in it, and we had a query that joined over 8 tables, which is not crazy, we had a table that, or we had something that joined over 8 tables, your result set would get very wide because it would just join all the columns on everything together. So as we can see, that would probably get out of control. We have multiple ID fields. We have multiple name fields. Excuse me. We have a price and a list price. So we need to start getting this under control. Well, so remember the question was, what items, what is the name of the items that Joel has ordered? Well, I can change my select star here to only give me back the columns that I want from this result set. So I can say that I only want item underscore, or not item, I'm sorry, items dot name. And let's say I also want users dot name. And let's get the price in which Joel paid for it, not the list price. So I would get that from orders dot price. So if you have joined to a table, this is very important. I'm going to put a lot of emphasis on this because this question is likely to come up this weekend. If you put, what was I going to say? Yes, if you join to a table or you select from the table, you can refer to that table in a select or anywhere else in the query, but only if you join to it. So like if I took this out here, if I took that user's join out there, this query wouldn't work. You'd get errors. So you need to make sure that if you are referencing items.name or users or orders or whatever, and you don't have a join or you're selecting from that table, it will not work. High emphasis on that.
And that's literally just table name and then
The column name. Yeah. So table name, column name. All right, so let's go ahead and paste this into here, and let's see what that has done to my result set. Ah, much better. But your business analyst is not happy about this. They say, can you please put the name on the name on the far left? And plus there's 2 name fields, so it's confusing. Can you please put, so first off, how would we move the username to the far left?
Change the order in the select.
Correct. I would change the order in the select. So I moved the users.name to the far left. Woohoo! And now we need to get rid of this problem where we have 2 name columns because our business analyst is confused when they see a cup of coffee with in the column name and think that that's referring to a customer. Ugh. So we can alias a column by saying users.name. We can say as, and then we can provide it. Let's say this is username. Pretty sure we can do that, or it will take double tick quotes. Yeah. Okay, I was right. So it's going to take double tick quotes on that one. I think. Yes. So that's where you would use double tick quotes, where you wouldn't use single tick quotes. When you're defining like a table or a column name that has spaces in it. So now look at our query. Looks so much nicer. We have username. We can even go so far to say item name as item name. Add that on there. And our business analyst will love us now. Look, we have username, item name, and price. This is a nicely written out table, essentially, that I can send them. And if I wrote this integrated into Python, I would be able to output this to Excel for them. So that's neat. Got that going for me. All right, let's write another query, and then we're going to take a little break because we did spend a little bit of time lecturing. I'm going to write one more query, and I could do all sorts. Like you can tweak these parameters. Like you can change where the user's name is Joel. You can do all sorts of awesome stuff like that. And I think that you should to get comfortable with this stuff. But what I want to do is I want to do a query where we want to get everybody who didn't pay list price. We want to get all of their names. Because eventually maybe we want to call, maybe make a phone call and say, hey, did you hack our system and you didn't pay the list price? What happened? Or maybe we just had a coupon code go awry and we need to go find the users who got that discount. So our query is going to say we're going to select star from items or from orders. And I want to inner join to the items table because that has the price on it. It has the list price and it has the price. Or the list price is on orders. The price is on the items table. So I'm going to inner join to items. And I'm going to say on orders.item ID is equal to items.id. I'm going to provide that a where clause. I'm going to say where orders. Let's see, what is it? Where orders dot price. Oh shoot, I always forget what not equals is. It's different in SQL. Not equals Postgres. Give me a second. I gotta look this up. Oh, is it really bang equals? Oh, there we go. So that's where I got confused. Like I've used the greater than, less than as the not equals, but if we can just use bang equals, that's even better. So where orders price is not equal to items.list price. See if this works. My spidey sense is actually tingling right now that this might not do what I think it does. Might have to come back to it. All right, so let's run this query and let's see what happens. Yeah, that's right. That's correct. We have all of the items in we have all of the orders where their price is not the same as their list price. Okay, now we need to get their username so we can talk to them. Like, what are all these usernames? So if you think that you know, just go right ahead, do your joins and change your columns to just show the usernames. But I'm going to type it out here. I'm going to say inner join to users on orders.userid is equal to users.id. And I'm going to change my select star to just be users.name. Leave that up there for a second. So that way when we run that, we have Joel, Sarah, Audrey, and Joel. Well, I sure as heck hope Joel doesn't get 3 phone calls. Because what's going to happen is they're going to take this list and they're going to divide it up between 5 people and say, you take the first fifth, I'll take the second fifth, third fifth, so on and so forth. So we only, here's one more thing, and then I promise we're going to take a break after this one. Is I only want to show the unique results. So I only want to show Joel once here. So you can say, here's an awesome little freebie. It's a one-word thing that you can add onto a result set to say select distinct user's name, which will return only the unique results from that database query. By the way, people spend their whole careers mastering SQL. Like this language, do you remember the lake of complexity of how I described it? Is this a narrow well that's deep? Is it a large lake that's shallow? Or is it a large lake that's really deep? It's a huge lake that's huge deep. Because of the way that they've designed the language, you can really just throw whatever you want wherever you want. It's got verbs, it's got nouns. It's like a Mad Lib. You can even drop in your stuff there as lowercase so that when you read your query, it's clear what you're saying. I kind of want to show you, let's say, intro to SQL. I kind of want to show you one thing that I really hate about everything in the internet. Is it here? No. Let's look at this PDF from Berkeley. Phil Spector wrote this?
Can't be.
No.
From jail.
Yeah, he got put away a long time ago. Well, let's see. We don't have it. That was fun. I'm glad we did that. All right. I want to see. There are these diagrams that people put for like understanding SQL syntax.
All SQL.
It's even weirder than a wall. It's a flow chart. Oh yeah. Sorry, the wall of sound. Gotcha. I wish I would be on that mindset. All right, doesn't look like we're going to get what we want there. Let me see. SQL language flow, maybe. Somewhere down the line, somebody thought, oh my gosh, is the internet dead? Did we kill Google? Did I just lose internet? Did we all lose internet? Somebody check that for me. There we go. List of SQL commands. Let's take a look at Codecademy. No, Codecademy is not going to have that. That is a really good resource, though. Look at that. I'm going to paste that into Slack for y'all. SQL language flow. Control of flow language, SQL introduction. Anyways, I may have to just come back to this and find it for you. Select statement Postgres. Maybe Postgres does a bad thing. There it is. That's kind of it. This is it just written out. I don't know how anybody finds this useful. I mean, I guess possibly that's useful to somebody, but it shows like all of the commands that you can use at any point in the command.
Did you post that?
No, not yet. I don't have Slack open. I'll do that after I stop the recording. I kept it open here, though, so I wouldn't lose it. All right, so this is just for select. And then if I told you, you can use these things called subqueries. So you can say, like, I want to search for all of this where the results are in this subquery. So you can have selects within selects. You can have, and then you can even create tables from the results of the select. So the rabbit hole goes extremely deep with SQL, and that's part of the reason why database administrators make a ton of money, because they are masters of SQL. They're masters of the hardware that it's running on. If you think that this kind of specialization would interest you, yeah, you can absolutely decide, I'm going to go finish this programming thing, maybe do a couple years in programming, but I want to focus on database administration. You will probably have to go some pretty specialized training for that. That's definitely not something you just kind of pick up on your own. And you'll probably chase after some certifications. But I'm telling you, you get an Oracle certification, you get a Microsoft certification on MS SQL, you're on the fast track to a high salary. So, because of the responsibility involved. Companies, data is their lifeblood. and so they need to trust in who they are and who they're hiring to do that kind of stuff. Anyways, that's the end of part one. When we come back, we're gonna start talking about the internet. Who's heard of the internet? Nobody's heard of the internet. Okay. Well, we're gonna have to go to GeoCities and we're gonna have to see what the internet's all about.